Today we're doing section 10.2, comparing two means, mu1 minus mu2. Describe the sampling distribution of x bar 1 minus x bar 2. Again, remember, describing a distribution, we use the acronym SOCS, S-O-C-S. That stands for shapes, outlier, center, and spread. Okay? For the sampling distribution, we shouldn't have any outliers, so just shape, center, and spread. The shape is approximately normal if the population is normal, or n is greater than or equal to 30 for both samples. The center is mu1 minus mu2, and the spread is the square root of sigma 1 squared divided by n1 plus sigma 2 squared divided by n2, as long as 10 times n is less than or equal to the population for both samples. Alright, confidence intervals for mu1 minus mu2. What are the conditions? Same as for one mean, just check for both samples. So remember, random, 10%, and normal. The formula for a two-sample t interval is parentheses x bar 1 minus x bar 2, close parentheses, plus or minus t star times the square root of s sub 1 squared divided by n sub 1 plus s sub 2 squared divided by n sub 2. Okay, remember we changed sigma to s because we don't know mu. If we don't know mu, we won't know sigma. Okay, the good news is we won't really use this. We're going to use the calculator to do the interval for us. Unless you just have to use the formula, just don't worry about the formula. It might come up in a multiple choice question, but you won't have to use it for the free response. Alright, calculator steps. This is the important part for the do step. Go to menu, statistics, confidence intervals, and choose two sample t interval. It's going to ask you if you want pooled, P-O-O-L-E-D, pooled, and you're going to choose no. No for pooled. Alright, let's do an example. Do plastic bags from Target or plastic bags from Walmart hold more weight? A group of AP Statistics students decided to investigate by filling a random sample of 5 bags from each store with common grocery items until the bags ripped. Then they weighed the contents of items in each bag to determine its capacity. Here are the results in grams. Construct and interpret a 99% confidence interval for the difference in mean capacity of plastic grocery bags from Target and Walmart. So notice it says difference in mean capacity. So that means mu1 minus mu2. Okay? So before we get started, we're going to go ahead and put our data from Target and our data from Walmart in our calculator. So let's go to a new document. Let's not save the old document. Let's go to a Lists and Spreadsheets page. Arrow to the top of column A and title it Target. Then go to the top of column B and title it Walmart. Then go back to cell 1 under A and type in the data for Target. When you're finished with that, go to cell 1 under column B for Walmart and type in the data for Walmart. Okay, we have to go ahead and do that because we need to be able to use the list to get our confidence interval when we do our calculations. So go ahead and put that in there now. Alright, so now let's do our confidence interval. State, plan, do, conclude. State. We want to estimate mu sub t minus mu sub w with 99% confidence, where mu sub t is the true mean capacity of plastic bags from Target, and mu sub w is the true mean capacity of plastic bags from Walmart. Okay, that states what we're looking for with 99% confidence, and it gives the parameters. It gives the confidence level and the parameters. Alright, plan. Plan checks the conditions and names the test. So we will calculate a two-sample t interval if conditions are met. That's the name of the test, two-sample t interval. And here are the conditions. Random, it's stated that it's a random sample. 10%, we assume 10 times 5 equals 50 is less than the number of bags at each store. Notice it says at each store. Not just one. If I do one for Target, I must also do one for Walmart. I have to check it for both stores. And the normal condition. Alright? Did it tell me in the problem that the population was normal? No, it did not. Are my sample sizes 30 or greater? No, they are not. So what must I do? This is where I have to draw a graph and check for strong skewness or outliers. Okay? So here's my dot plot for Target. Here's my dot plot for Walmart. There is no skewness or outliers. So we're going to go ahead and proceed. All right, then comes the do step. All right, for the do step, go Control Doc to add a calculator page. Then go Menu, Statistics, Confidence Intervals, 2 sample t interval, and we have raw data, so go ahead and select data. And then for list 1, select target. For list 2, select Walmart. Leave the frequency for both of them as 1. And for sea level, do 0.99. And for pooled, do no. I get degrees of freedom equals 7.51. And my interval is from negative 100.9 to 7,284.5. All right, conclude. State plan, do conclude. That's the last step. We are 99% confident that the interval from negative 100.9 to 7,284.5 captures what? What were we looking for? The true difference in means, mu t minus mu sub w. And you can leave it as mu t minus mu sub w because you've already defined them. Or you can go ahead and write it out. The true difference in mean capacity of plastic grocery bags from Target and Walmart. All right. Does my interval provide convincing evidence that there is a difference in the mean capacity between the two stores? Okay. If there is no difference, then 0, right? Their difference would be 0. All right. Is 0 in my interval? Yes, because I go from a negative number up to a positive number, I have to cross over 0, right? So no, because the interval contains 0. I don't have proof that there is no difference. All right, significance test for mu1 minus mu2. Conditions. Same as one mean, just check for both samples. Test statistic for a 2 sample t-test for mu1 minus mu2. All right, t equals, parentheses, x bar 1 minus x bar 2, close parentheses, minus 0, divided by the square root of s1 squared over n1 plus s2 squared over n2. All right, again, we're not going to use that. We're going to use what the calculator gives us. All right, for degrees of freedom, there's 2 ways to define degrees of freedom. If you're going to do the test statistic by hand, if you're going to use this formula t equals, then to get your degrees of freedom, you do the smallest n minus 1. If you're going to go the smart route and use the calculator, then you get the degrees of freedom from the calculator. Okay, calculator steps. Here we go. Menu, statistics, stat test, 2 sample t-test. Again, choose no for pooled. All right. Next example. In commercials for Bounty paper towels, the manufacturer claims that they are the quicker picker-upper, but are they also the stronger picker-upper? 2 AP statistics students decided to find out. They selected a random sample of 30 Bounty paper towels and a random sample of 30 generic paper towels and measured their strength when wet. To do this, they uniformly soaked each paper towel with 4 ounces of water, held 2 opposite edges of the paper towel, and counted how many quarters each paper towel could hold until ripping, alternating brands. Here are their summary statistics. Use a significance test to determine if there is convincing evidence that wet Bounty paper towels can hold more weight on average than wet generic paper towels. Okay, significance test. So here we go. Let mu b equal the true mean number of quarters a wet Bounty paper towel can hold, and mu sub g equal the true mean number of quarters a wet generic paper towel can hold. We want to test the following hypotheses at the alpha equals 0.05 significance level. Remember, when they don't give you a significance level, you go with 0.05. Okay? My null is m sub b minus n sub g is equal to 0, or preferably, what I prefer, mu sub b equals mu sub g. The alternative is mu sub b minus mu sub g is greater than 0, or mu sub b is greater than mu sub g. Again, I prefer this route because this is what the calculator does, but you can go either way. All right, that was the state. Let's go to plan. We will perform a 2 sample t-test if conditions are met. First condition, random, stated random samples. 10%, we assume 10 times 50 equals 500 is less than or equal to the number of 10 times 30 is less than or equal to 300, or equals 300 is less than or equal to the number of paper towels for each brand. Sorry about that. And the normal. Because my sample is 30, and it's 30 is greater than or equal to 30 for both brands, I'm good to go. Alright, so here comes the do step. Let's go to your calculator. In a calculator page, go Menu, Statistics, Stat Test, Choose Sample T-Test. This time we have stats, so go from data to stats. Okay. And then you're going to enter the information they give you from Bounty and Generic with the problem and choose No for pooled. Degrees of freedom is 57.84. T is 17.65. And the p-value is approximately 0. Okay? Don't look at that 2.9 without looking at the e to the negative 25. Okay? Some people miss the e, don't miss the e. That means it's approximately 0. So here we go. Conclude. Since the p-value approximately 0 is less than alpha equals 0.05, we reject H sub O. There is convincing evidence that Bounty paper towels can hold more weight on average than generic paper towels.